Okay, hello everyone. Thank you for joining our session today about securing your application development deployment using Terraform and Azure DevOps. So we have here Abdel Halim will present our session today. So we are really glad that we have him and we have all of you to join our session today. So I will hand over to him to start presenting. Thank you.
Thank you, Muhammad.
No problem.
So is my screen
Yeah,
is visible now? Yeah. All right.
absolutely.
So I will start by introducing myself. My name is Abdel Halim Zaki, and I have 4 years of experience as a DevOps engineer. Also, I'm a member of DevOps Vision, and we share knowledge and experience with our members. Also, I'm a certified DevOps engineer. And today we have the chance to share some experience with you from our community. So today we will learn how to securely deploying applications with Azure Active Directory authentication and Terraform. So let's jump to our today's agenda. We will start by identifying what is DevSecOps, Azure Active Directory. We will go over infrastructure as a code, Azure pipeline as a code, deploy your apps securely. And this part, we will start breaking down our code a bit by bit and highlight the most important parts to show the true art of automation and how to take advantage of the common tools that you use every day and leverage its full potentials. Then, if you want to do the demo yourself, then we will talk about some prerequisites that you need to make sure that you have. Then we will see a demo, seeing everything in action and watch deployment happening. Then at the very end, we will have question and answer. Also, if you have any question, you can type it down in the chat and we will get back to it at the end. So let's start. Well, before identifying what is DevSecOps, we have some challenges around the software development lifecycle. One of it is development teams want to develop new features and go faster to market. And security team want to do everything possible to keep the environment secure and prevent breaches and vulnerabilities. And operation team, they are the anchor that's holding you back because they want a stability over everything else. And today, DevOps methodologies, agile methodologies, practices, and principles, delivering those and solving some of the challenges. But in the modern world, is everyone is actually adapting practices and principles and tools among it? Actually, that's not always the case because some companies actually adapting some tools only and they say they have adapted the DevOps, but that's not actually the case. So what actually the normal DevOps flow that we see inside companies nowadays by adapting only tools? So we start by a developer, they write the code, push the code to the Git. You can use Git, GitHub, whatever. And then the Git will have some triggers to trigger up your CI/CD pipelines, which will build your application. And maybe you can use Docker containers, normal application builds. And then after that, we will go to the continuous deployment. We will trigger the infrastructure as code to build our infrastructure. We will have resource group, app service, SQL, and SQL Server, also some monitoring tool, all prepared by our EAC. Then we start deploying our container. Then we can do as many environments as we need. We can have one environment, 5 environments from production, and so on, because we have the EAC can help us make it that easier. And this is the real problem because they still put the security in at the end of the cycle. Yeah, security doing great job here by trying to maximize what they can do and secure our environments. but still they gonna miss a lot. Also, we have the monitoring. So this is a huge problem right now. What we can do to actually solve this? And before we jump to the solution, we need to identify something important. Something important. If you are a developer, if you are a security, and if you are an operation, actually security is everyone's responsibility. So everybody have his part to play on that cycle. So right here, we identifying more and more. We need to integrate our security into the automation pipeline and the automation process. And there is a lot of benefits that you can get from security automation. So you make less human interaction, less errors, because human tend to forget. Yes, we are great, and we made a lot of good invent. We made a lot of good projects and stuff like ChatGPT and everything, but we tend to forget. So less human interaction, security automation means it's more reliable, effective, and also it's scalable. So if you apply everything in dev environment, it will be replicated to the production environments. And it also gave us the ability to identify and fix potential vulnerabilities early on and reducing the risk of security breaches. So what is the DevSecOps flow should look like? So it starts by a developer writing the code, push the code to the Git, but now we adapting an agile methodology and a DevOps principle called shifting left. And shifting left actually is moving the security to left of the development process. So you start your security measures as early as possible. That give us the ability to make security scanning over the code, quality measurements, and also scan dependencies that we are use for vulnerabilities and performance. Then we integrate it more and make every bit of the pipeline run by security tests. And the normal flow, we will build our application after we make security scanning and vulnerability checks and everything for it. Our EAC will do its job, build our environments, and then deploy it. But actually, there is more to it because you can make your CI/CD pipelines and infrastructure as code handle everything in the back for you. And that will be the major thing for our Azure Active Directory will jump into play because Azure Active Directory is giving you the ability to making identity for each application and each resource that you have inside your organization. I'm not gonna say a lot in here. Let's jump to the next slide. So for you who doesn't know what is Azure Active Directory, Azure Active Directory is a centralized solution that helps us protect organizational resources and data by providing identity and access management capabilities. And it have more capabilities than it is. Actually, we're gonna just highlight some of the capabilities. It starts with authentication and authorization. Also, it gives you the ability to implement an extra layer of security by implementing multi-factor authenticating into your organization. Also, it delegates the complex identity management by providing B2C, which is business to customer and business to business collaboration that allow integration into your application, which provide more advanced identity management for your organization out of the box. Also, at the end, there is the managed identity. Managed identity in Azure Active Directory is giving each resource inside your organization and each member inside your organization an identity. And it can do seamlessly authentication between the resources without the need of traditional username and password, and that actually eliminate the chances and lower the chances of the security breach. So let's see how we're gonna take advantage of those. But before we start, we need to mention something very important right here, which is everything as code. So for you who doesn't know what is everything as code, it's an approach by IT operation and DevOps engineers to actually identify everything that they use and they can transfer into a code to a code format. And to actually understand why we are doing this, we need to check the benefits of everything as code. Everything as code is constant. When you're building an infrastructure, it will be the same across all environments. It's scalable because we have the same thing. We can, by a click, we can provision as many environments as we can. Also, there is auditability, which we can only edit and change in one centralized template, and it will make the flow itself for everything else. Also, it can give us reusability. I can use the same code for as many projects as I can. I can use it in project X today, and I can use the same code by changing only the variables for project Y tomorrow. So after getting a glimpse of what everything as code is providing, we gonna go over infrastructure as code, or call in today is IAC, and we will go along with Terraform. And Terraform is actually one of the most popular IAC tools today, and it's provided by HashiCorp. And we will review some of best of practices for Terraform that we will use and apply today. So we will start by why actually Terraform is famous. It's because it's giving us the ability of something called statefile. Statefile is giving us the ability to track down your resource and check out when you make a change, and to check the actual status of your resource right now and compare between them and then take an action. So we need to keep those state files in a centralized resource, which is it's recommended to keep in a storage account, an S3 bucket, and so on. And then in terms of reusability, you need to avoid variables hard decoding as much as you can, because it will make your life harder if you have some variables hard coded to actually reuse these templates. Then also using constant naming convention will help you identifying your resource and make everything um, align together. Also, at the end, you need to make sure to tag your resources to be able to to identify which resource following which project really fast by just looking at the resource on the Azure portal. We will start by breaking down some of the code we have, and we will start by Terraform. So in the picture in front of us right now, we have the first part, which is called CLI arguments. Let me laser pointer. Yes, this one. So in the first part, we have CLI arguments. So the CLI arguments are actually coming from the pipeline. By activating the true automation, you can make everything automated by identifying your variables inside of the pipeline, and it can pass the variables to the Terraform, and Terraform can handle that. So we have an arguments or some variables coming from the pipeline side, which is the pipeline URL, the environment name, the project name, and the privileged user that should have access to the application or the SQL database. Then we have some of the environment arguments, which is referred to the, the .tf bars. So let's say you want to make your app service with a different SEQ on lower environments than the higher environments for production. So for example, for production, you will use V1, V2 app service, and in the lower environment, you don't need to spend that much, so you will use something else. So by identifying as a variable in each TF var, it gives you the ability to do that. Then we will have our local variables and our comment tags. Comment tags here have timestamp when this is created, who created this, which environment it's follow, and what is the pipeline URL. So it gives you easier access to check the pipeline if you want to go back and check some logs if there is an error happened. And the rest of the variables.tf, we also have a section called backend. So since we are not hard coding anything into our templates, we are identifying our organizational resources variables right here in the variables.tf. So we have our organizational resource group called rg-main resources dash production. Then the TF state storage account, we will have it by the name TF state DevSecOps demo production. Then the container that will contain the TF state file will called TF state dash CRUD demo. Also, we have the name of the ACR, the name of the SQL server group. That's the group that have the SQL server administration members that have the ability to access SQL Server and have some edits and stuff like this. Also, at the end, we have the name of our service principal that run our pipeline, our Terraform, create everything for us in Azure. And at the end, we have our naming convention for our actual project. And you can notice here that our naming convention is starting with the same thing for everything. So, by example, for the resource group, we have RG, firewall as ARC. If we have a key vault, it's called AKV, app name, web app dash. Then everything is followed by the project name, then everything followed by the environment name. So normally, we will have the same naming convention for all our resources. Then we have Terraform. We need to take advantage of more and like maximize the benefits that we can get. There is something called data sources in Terraform that call certain objects, and we can use those objects to call some of our resources that out of our infrastructure or current infrastructure. So in the first section right here, we are calling the ECR registry name, which is ECR organizational Halim demo DevSecOps production and calling the resource group name. Then we calling our client config, which contain the tenant ID, the subscription ID, and so on. Also, we are calling the Azure Active Directory client config, which will give us the ability to start data for Azure Active Directory group. And we calling right here the SQL Server group to create a new identity for our new application inside of that group to give it the privilege of being an admin. By moving to the main.tf file, we can see that here we started identifying our actual infrastructure that we can have. So we calling our backend first that will contain our TF state files. So by calling the resource group name, and then it's RG main resource group production. That's the main resource group that have all our global resources for everything. And we call the storage account name, and then we call the container name, which will contain our TF state. And if you don't have a TF state for this specific project, Terraform will create it for you in the automation pipeline. And then we will create our main resource group, calling resource group, where is its location, and we will have some tags that we identified earlier. And then by going to the app service, we have identified two authentication module here today to actually show you the difference on why you should move to using identity in your deployments. So in the first one, we have created our organizational Azure Container Registry by the normal authentication as an admin and username passwords. And the second one, we have created our connection string by only leveraging the authentication as an an Azure Active Directory default, which will at the end will authenticate our application to the SQL database by only using the identity. And here's a close picture show that we have used the data source to call the password and username. And even if you are using data source to call your resources by using Terraform, it's not making it 100% secure. And we'll see that in the real video and the real demo that we can see password and username in plain text. So by moving to the SQL Server, we have here an Azure AD administration. Also, we are making the Azure AD administration as the service principal who actually run everything for us and create all the resources. And this service principal can actually take it a bit further and make SQL queries inside of the SQL Server by some automation. So you have less and less human interaction. So if you want to give a set of developers an access to the SQL Server, you only, or the SQL database, you only can run a query as a part of your pipeline. And at the end, after we create everything, you also have the Terraform output, which will give us the application name or the app service name, the database server, and the database name. We will take those output and also integrate them into the pipeline and take advantage of the objects that we have received from Terraform. And we will start doing that by breaking down our pipeline flow. And this is our pipeline. We have a main build and deploy template, and we have some minor templates inside of the folder called template. One gonna actually build and deploy Docker for us. Other one will contain everything for the flow. One gonna be responsible for the Terraform, and the last one will be responsible for the SQL queries. So let's start breaking down the main build and deploy template. So first, we have our normal trunk-based branch triggers that we will handle all our BRs and commits to the main branch. So everything that happened in the development process will happen into the main branch. And then when we want to trigger a new release, we will create a new branch with release, then the version or whatever the name convention that we use inside our company. And By creating the triggers, we also make some variables conditioned to those. We have some deployment groups that contain some conditions, and we will explain and go to that in the next slide really quick. And that's not it only. So we have identified our deploy groups, and then we will move up to the rest of our template. Since we said we want to be able to have a reusability for our templates, we have identified every variable that is going to be used inside of our templates in the main template. So it gives us the ability, if you want to use this in another project, you're just going to change those variables. And then our first stage in the pipeline is the build, and we are referring to our deploy Docker template. This template will be responsible to build and push and deploy your Docker container into the environment. Then we have some condition for the deployment group. So if any commit happen to the main branch, it will trigger the, the environment, which called dev, and the environment QA as a development process. And if we got a new branch called release, it will start a new environment process, which is the other environment, which is pre-production and production. And you can notice here that the access group is the same for dev, QA, and pre-production, because in the lower environments, every developer needs some access to those environments. But in the production environment, you need to limit those access. So the group is changed in the production environment. So right here, we have even in the pre-production, since this is a simulation of production, A Corp devs can have access, but in the production, only production access group members can have access to the production environment. And right now, we will highlight how Terraform actually handle the CLI arguments. In this part, in the Terraform plan task, you will see that we are passing the variables that we have identified in the main template as -var project name, and we inherit the project name by its variable. And the Terraform, as we mentioned earlier, will take this project name and do its naming convention as it is, as it's identified in the variables DF file. Then after Terraform created your infrastructure, we have now the outputs. And by taking advantage of those outputs, you can actually make them into variables. And right here in this variable section, we actually calling the Terraform outputs like this. We call the stage dependencies, and we identifying which environment that we're gonna call, then which Terraform outputs that we're gonna save into this variable. It's the DB server. We're gonna call it now SQL Server name. Then we're gonna do the same for the database name. Then for the application app service or API application name, we will save it in the last variable. Then we will take an advantage of those three variables and pass them to the next template that we have, to our service principal that will run SQL Server query and give access to the application, the developers that are responsible for this environment, everything in the same place as an automated task. And we can see here an example of the SQL query that's running by the service principal. As you can see here, authentication type is service principal, and we have the service principal variable that we identified in the main template right here. And then, since we identified our service principal as the admin of our SQL server, it will be able to run any query that we need. We will give permissions to the application, to the app service, and also to the group of members or group of developers that need access to that SQL database. I hope that was clear enough. And before we jump into our demo, we need to identify some prerequisites that you need to pay attention to if you want to do this demo yourself. Also, I need to mention that we will have the source code of everything you have seen today uploaded onto GitHub. So don't worry about this part. So before you start your demo, you need to make sure that you have created a service principal into your Azure DevOps, then created an Azure Container Registry service connection between Azure resource, between your Azure global resources and Azure DevOps, created the required backend. Like if you don't have your main organizational resource group, you need to make sure that you have the storage account, the container, and everything ready for your Terraform. And then if you are doing this in a fresh organization, you need to create some groups and give them some permission access on Azure Active Directory. So right here, this is an example of the service connection here, SPN-resource. This is the service connection that you need to create. And also this is the ECR or Azure Container Registry service connection between the resource. Also, even though that you have created your service principal, you need to make sure that you have given a specific API permissions, because if you're doing this in a fresh Azure Active Directory, you probably don't have rule-based access control or any attribute-based access control setup for your environment. So you need to make sure that your service principal have application.read_all, group member.read_all, and user.read_all. Then, as we discussed earlier, we need to create some groups and put some members inside of them, because those are developers that need access to our environment. Uh, let's see our demo. Uh, the screen is visible. All right. So right now, you will start triggering our demo by making a demo trigger to the main branch, which is you should not do in a real world scenario. You should create a BR first, but this is just for a demo purposes. After committing our changes and push it, we will go to our Azure DevOps organization and check the pipeline. And right now we will see demo trigger init, and it's in the build process right now. If we go inside of it, we can see that we have the build process running. Then it will move to the next stage, which is the dev, building the dev and deploying the dev environment. Then after that, it will make sure that the DB, dev-db deploy, get its access by running the SQL queries. Then if you want to also spin up the QA environment, you can do that in the same process, since we have identified the deploy group earlier. So this is our normal Docker build, and this is a sample application of just doing CRUD. So I didn't go further into how to make the Docker file. And yeah, as you can see right now, it's just normal Docker file that just copy the CS project, run.NET build, then publish it, then make a full container out of it, push it to our SCR, and make an image that we can retrieve and deploy into our app service. Now it's doing its Docker push. So Terraform will take a lot of time, so I will fast forward it. Before that, we need to go into the plan and show you the difference between the identity and of authentication as username as password. We will see the Azure Container Registry username and password as a plain text in the pipeline. Yeah, Terraform takes some time. Yeah. Now it's deploying the web app. Now it's running the SQL queries by using the service principal as the SQL Server admin to give the group of developers the permission over the master database and then give them the permission over the database that they have, which is SQL DB dash DevSec OBY dash dev. Then it will give the app service the permission over the database so it can authenticate its identity. And this is so if I want to spend QA environment, I can just go and permit the QA environment to start its deployment. So let's navigate and check our infrastructure. We'll navigate to Azure and then check our application right now and check if that everything in the process happened correctly. We will go to the URL and navigate to the students menu and click create new. And right now, if we don't have access to the database and try to make a create, it will prevent our access, and we will see that in just a second. So right now, if we try to create and we have access to the database, we will create a new student name into the database. We created the first one and called Halim, and then we will create another one and call it Radwan. And also, as you can see that our CRUD demo have full potential over the database. We have created, we can delete right now, and we can also edit it. And by logging into, and also to give you a glimpse about the MFA access and the true power of Azure Active Directory, I have created a new username inside my organization and called it halim.devsecops. And now I'm getting access to it. And it requires me to actually go to my phone and give it an authentication. So we're going right here and we're gonna change the admin of the SQL database. So we will move the admin of database as halim.devsecops, and we will remove the identity of the app service from the database by running a SQL query, which we'll see right now. We, I will allow here, I'm allowing the IP address. Then we're gonna drop the user of the web app DevSecOps from the database. So we deleting the identity from the database. Let's just check what's gonna happen after that. So by going back to the application and try to refresh, you you don't have any access anymore to the application because it cannot authenticate you with the identity because we have removed the identity. So anybody that don't have proper access to your SQL server, it's only gonna authenticate it with identity. So right now, you don't have any security breaches and afraid of that your username and password of the SQL Server has been breached, and you have less and less vulnerabilities and also more secure environment. That's the end of our demo, and that brought us to the end of our session and start of the QA.
Thank you so much, Halim. I really appreciate that. Also, yes, this is a question and answer. So if anyone has any questions, you can. We are happy to hear that. And before we forgot, we will leave a survey in the chat, so you can leave. I would I would really appreciate if you could just give us your feedback. This will be really appreciated, so we can get better understanding of how we can improve or what is went well and so on. Okay. Is there is any questions?
No questions at all?
No questions? Yes, Suhaila. Um, I'm not sure if anyone can tell me if we don't have any English people, we can even, but no, we have. Okay. So yes, yes, Suhaila, come on. If you, uh, what's your question? Or this was by mistake that you raise your hand?
Sir, I just typed it in the chat because I had to raise my hand because I
Yeah,
didn't want the meeting to end without typing anything.
yeah.
I wanted to ask about distributed computing systems, like deploying a multiplayer app or like a distributed system on Azure. I think this was my question.
Mhm.
Can I use a TF file for that, or can I can I actually use what we've explained today doing that?
Yeah. Yes, would you like to answer, Abdelhaim? I think you are working now in many projects with Terraform and so
Yes, in terms of infrastructure and everything, yes, you can use Terraform and build that. But by going into the technicalities of applying that to multiplayer games, uh, actually, that's not my kind of expertise right now. I cannot give a say, but I'm sure if I have an answer, I will deliver it back to you.
and in general, when you start looking at distributed system, distributed system is just as like small components, no matter what it is, this component. It could be like queuing system, it could be in caching, it just matter of several components. And with Terraform, there is a structure of modules. So you will have bunch of Terraform files that is distributed also over different modules, Terraform modules. And then, it will be based, or if you would like to replicate all, you like provision the whole distributed system, or just creating, or updating only one component. So as I mean, what I'm trying to say in the end is, as you saw, is when you have a Terraform for infrastructure as code, this could be like 2 or 3 components, or could be 100 components. So it will work the same. I think it will be just like you work with Terraform modules. So you can be, Terraform modules. This is something like function. So you can have reusable component with Terraform, and instead of writing the same Terraform again and again and again, repeating the same code.
Thank you so much. I understand I might have been vague, but thank you so much for everything.
Yeah, no problem. It's our pleasure. Any other question? Any other question outside even the session? We are happy to take them.
Yes, we still have time. It's your chance.
Okay, I left the survey in the link. Please, we really appreciate hear your feedback. So this would be really great. There is another question asking about what is the right environment to build a server. I'm not sure, Abdel Halim, if you understand the question or
Actually, it's no.
what you mean, Abdel Hakim? What you mean by the right environment to build a server? Can you elaborate more about your question? Okay, no problem. Okay, so I think maybe do you recommend a book for DevOps? Yes, okay. So there is some, I will say there is some very known books for DevOps. One of them is the Phoenix Project, and another book is I can you remember? Yes, one of the very famous projects as well, which is very important, is the continuous delivery. Which is one of this book I think is identified the principles of the continuous delivery. I think if you write continuous delivery, you will find that on Amazon. And the Phoenix project, I think there is two more books, but I can't remember them now. But yes, you can reach out to me and I can share that books. I'm sure I can remember that later. And of course, Abdul Halim, if you know any book or
Actually, yeah, I started reading Phoenix Project as well. It's really amazing and
yeah,
enjoyable. Yeah, but I don't have anything at mind right now.
okay. So I think it means how to choose. Sarah, I think she's trying to help the elaborate about the question. I think he means how to choose the right solution for building the server. Uh, I think it's all about what does it mean by building the server. I mean, server. If you are if you are talking about provisioning, provisioning the environment or provisioning the server, this is what you mean by building the server. Like creating the server, provisioning the server. So it will be usually, yes, infrastructure as code. Either it is Terraform or uh, as how Abdel Halim is showed us in the demo, or it could be some other technology. It could be Ansible or maybe ARM template. So yes, this will be the same.
Yes, I would like to add also, if you mean by building a server, choosing which module you're gonna follow, if you're gonna follow to platform as a service or infrastructure as a service, there is nothing here about wrong or right. It's more about what actually your needs, what's actually your business needs. Some maybe you have small applications that you can actually go to platform as a service, as I showed today, and actually hold them in application service or app service. Maybe you have a larger infrastructure. Maybe you have tons of containers and you have Azure container services. Maybe so you're gonna go into uh, Kubernetes and actually provision a cluster into Azure and start using it. Maybe you just need a traditional virtual machine and you need more control over your infrastructure. So there is actually nothing about wrong or right. It's more about what is actually your needs. What do you need? I hope
Exactly.
that cover what you mean.
And I think this is very important when it comes to talk about either it's programming or even building some solutions. There is no right and wrong usually. Again, it's all about, maintainability, reusability, efficiency, and, measuring that. I usually say, like, if for example, if we decided to, like, one with 20 years of experience, and maybe a developer with just 1 year of experience, and building a calculator, maybe the calculator would work the same. You just click on the buttons, making some, calculations, and it will look the same. But all the change, or all the difference, it will be how you build that. And to understand that, what it does it mean. For example, if there is a new requirement from the experience, how this will impact your change. Maybe, for example, with one of 20 years of experience, then they were just changing a line of code because the code is high maintainable, it's encapsulated, but for, if it is without really good experience or clean code or something like that, it will be like require a lot of change, and taking long time. So what I'm trying, I think, is Abdul Halim just to trigger very important point for me. There is no wrong or right. It's all about the efficiency, and this is why when we start, for example, if you have an interview, either it's development or even infrastructure as code or anything, they will start evaluating your code, not it is working or not. Of course, this is the first step, but the second is the maintainability, the reusability of the component, how you think of reusing that, and so on. So yes, that's the point I wanted to mention here.
Yeah, that was impressive. Thank you, Mohammed.
No problem. Yes, it just because, yes, your target not always, of course, this is the ultimate goal, is to that you have something that is work, but the most important is other dimensions. Okay, do this automation and security. Let me check. Uh, does this automation and security, or do and considerations eligible for KES?
Kubernetes.
Yeah.
I
Yeah.
haven't done it myself, but since we are going to using the same methodology, since we are not limiting the true power of Azure Active Directory or Terraform by only limiting it to the app service. You can do this to anything actually. It's the identity, it's the core concept that we are wanted to talk about and highlight because uh, because this technology has no it's like a new technology actually. It's got released mid 22. Yeah, it's about mid 22. So actually Microsoft's giving us out of the box solutions to make your life easier. So by making the identity is the core authentication in your organization, yeah, that's doable because it's gonna treat the Kubernetes if it's gonna treat the Kubernetes by its identity. So I guess it's doable. I haven't done it yet. I don't know what is the complication that you're gonna face while trying to applying that in real life scenario. But yeah,
Yes, in the end, everything now can be automated. I think also Abdul Halim mentioned in the beginning, everything as a code. So you can think now we have everything as a code, infrastructure as code, configuration as code, database as code, even docs as code or documentation as code, policy as code, which is security principles and so on. So now everything can be, under version control, and then run some automation pipeline which can configure or apply. And this is what we call GitOps. So absolutely, this can be applied. It should be, Okay, so I think now let's yeah, that's fine. So thanks again for joining the session, and we are looking forward for seeing you again for other future sessions. Thank you.
thank you everyone. Thank you, Muhammad.
Thank you.